This lesson is about solving quadratic equations with the zero product property. Sometimes we call the zero product property, sometimes we call it the ZPP, so just get used to that, okay? Zero product property really means that the equation you are given, we're going to be given an equation, so it's going to say equal something, it has to equal 0 for this to work. If it doesn't equal 0, there's something you can do about it to make it equal 0, and we'll talk about that in a little bit. Okay? Also, something that you should know is that the word solving means solving for a variable. So we're going to be given an equation, right, that equals 0. We're not going to solve for 0. We're going to solve for some variable on the other side of the equation to find out what we can plug in to make the answer 0. Now, the type of equations we're going to be looking at are quadratic equations, which means they are equations that have x squared as the highest power. There might be other values too, like there might be a number here, we'll call it number a. There might be a number here next to the bx, and there might be just a number all by itself. And some of those might be positive, and some of them might be negative numbers. They could be fractions. They can be all sorts of things. So generally, this form of the quadratic equation is called the standard form. If it equals 0, we can use the zero product property, but not quite yet. The second word in the zero product property is product, which means we're going to have to rewrite this addition problem right here so that it looks like a multiplication problem, because product is the answer to a multiplication problem. So in the end, you're going to have something times something equaling, not equaling x, equaling 0. Sorry. Okay, so let's look at some examples. I'm going to start with a really easy example, and then we are going to go on to a harder example, and then a harder one, and then a harder one. Okay, so example number 1. This is the easiest we can do. This particular quadratic equation you might not notice is quadratic right away because I don't see an x squared. However, I know that these parentheses mean we're going to multiply, and if we do, there will come a point where we would multiply the x times the x. We're not actually going to do that, but when you multiply an x times an x, you get an x squared. So I do know that this is indeed a quadratic equation. Now, I also know that we have a multiplication problem with 3 different factors. We're multiplying the number 3, the expression x minus 5, and the expression x plus 1. And we want to solve this and find out what x is equal to. Notice, this is good. The answer right now is 0. Okay, so what I'm thinking about is anytime I multiply and I get an answer of 0, one of the terms that I multiply must be equal to 0, right? Or all of them. Well, first of all, we have 3 things being multiplied. Something here has to be equal to 0. Now I know the number 3 cannot be equal to 0, so that's not it. I do know x minus 5 could equal 0 if x equals positive 5. Now, if you don't quite remember how to figure that out, I mean, you can probably do it in your head. What minus 5 equals 0? You could just add 5 to both sides if you're really stuck. Some of these problems are harder than this one. Like I said, this is an easier one. So we get x equals 5 as one of our solutions. Or we could say x plus 1 equals 0, in which case, subtract 1 from both sides, x equals negative 1. Again, most of you can figure that out in your head. So our 2 solutions, we don't have 3, even though there were 3 factors. The 2 solutions are x equals 5 or x equals negative 1. All right, let's try a medium problem. Now, looking at this quadratic equation, sadly, it is not in factored form. So we can't use the zero product property until we rewrite the equation as a multiplication problem. Now, you should remember we can use the X box to do that, right? I'm going to do that right now. I'm setting up my X box. In this case, my X box equals 0. Okay, let's see. So the x squared always goes on the bottom corner, and the number itself, the number by itself, goes on the top. If I multiply that first and last term, x squared times negative 10x, I put that in the bottom of my x, and in the top, and the bottom gets this missing term right here, the negative 3x. Okay, sorry, let me just put that right there. Negative 3x goes in the bottom. Now I have to figure out what two factors multiply to make negative 10x and add to make negative 3x. Oh, that's gotta be negative 5x and positive 2x, right? Multiply to negative 10x squared and add up to negative 3x. Okay. Negative 5x, 2x, and now I'm ready. I can figure out the factors. This corner has to be an x times x to make an x squared. Looking up, x times negative 5 is negative 5x, and looking across, x times 2 is 2x. So to guarantee I'm correct, I'm going to multiply the negative 5x, the negative 5 and the 2, and I get negative 10. So my factors are x plus 2 and x minus 5. Now that it's factored, I can use the zero product property. Let's go ahead and do that. There's only two things being multiplied. They both could equal 0. If x plus 2 equaled 0, then x would equal negative 2. That's my first solution. If x minus 5 equaled 0, then x could equal positive 5. That's my second solution. So, done. All right, here's a slightly harder problem, okay? In this particular case, you notice the answer is not equal to 0. We do have the x squared, we do have a quadratic equation, but it's not equal to 0. That's okay. If I move some of these terms around, like if, for example, if I subtracted x squared from both sides, I would end up with 0 on the right. I would also have a negative x squared on the left. I'm going to do it the other way, actually, because I just have this preference of having my x squared be a positive value. So what I'm going to do is I'm going to subtract 3x and subtract 10 from both sides, okay, from both sides. So the left side of this equation, after doing that subtraction problem, would equal, yeah, you got it, 0. And the right side would be x squared minus 3x minus 10. Okay? Again, I could have done it on in the other way and had negative x squared plus 3x plus 10 and done the x box. So yeah, so the next step would be to use the x box, but you know what? I'm just noticing this is the exact same problem as on the previous slide. Not this one, x squared minus 3x minus 10. I did that on purpose. So you can use the same steps and solve for the variable x that way. And there'll be two solutions. Okay, one more example. This is the hardest one I could come up with. Here is an example where there is a negative in front of the x squared. I don't like that. So again, I want to get rid of it. One thing I could do is I could add 6x squared and subtract 45 and subtract 21x and move it over to the other side. Another option would just be to multiply both sides of the equation by -1, right? And that will make everything that was negative positive and everything that was positive negative. So the new equation would end up looking like this: minus 45 minus 21x. And 0 times -1 is still 0, okay? Another issue, do you notice that the terms aren't written in our favorite order where we have descending values of exponents? Like we want this term with the x typically goes right in the middle if we were going to write this in standard form. I could just rewrite that pretty easily. X squared plus 21x. Oh, I'm sorry. Why did I say plus? I'm lying to you. Minus 21x minus 45. I'm just moving around the order of my terms. That's all I'm doing. Okay. Next, these are really big numbers. So I want to factor out a common term. I'm noticing that the number 3 goes into 6, negative 21, and negative 45, right? 3 goes into all of them. So I'm going to just sort of factor out a 3. 3 times 2x squared makes 6x squared. 3 times 7x makes negative 21x. And 3 times negative 15 makes negative 45. It's still equal to 0. Whew, finally, I'm ready to do the x box. Okay, but this time when I do the x box, there's going to be one more term, which is just the number 3. And the whole thing is equal to 0. All right, let's see how this goes. Once again, all right, let's plug in our values. 2x squared goes here. I'm just happy to use smaller numbers. Negative 15 up here. So we have negative 30x squared on the top of our x and negative 7x down there. All right, what could it be? 5, 10, and 3. 10 and 3. So if I had negative 10x and positive 3x, right? Those add up to negative 7x and they multiply to negative 30x. Super. Okay, so I'm going to plug in 10x and, negative 10x and 3x. And now I have to figure out the factors. I'm going to put the 2x down here, knowing it goes into negative 10, and just an x over here. Yeah, 2x times x make 2x squared. Going across, x plus 3 okay, so 3 times x makes 3x and negative 5. 2x times negative 5 is negative 10x. Okay, I'm going to hope I can get enough room to rewrite my factored form now. I have a 3, I have a 2x plus 3, and I have an x minus 5, and it all equals 0. Okay, you're going to have to bear with me because I'm running out of space, so I'm going to have to move over to another side. Okay, one thing I know for sure, I'm multiplying 3 different things. They all equal 0. I know 3 does not equal 0 ever, right? So that's not where one of my solutions is. I do know 2x plus 3 could equal 0. And I also know x minus 5 could equal 0. Now let's find out what x's make that happen. X minus 5 is pretty easy. I just add 5 to both sides, so I get x equals 5. There's one of my solutions. 2x plus 3 equals 0 is something you might not be able to do in your head. That's okay. Let's subtract 3 from both sides. We have 2x equals negative 3. And now we're going to divide both sides by 2. X equals negative 3 over 2, which is also known as negative 1.5. And that is our other solution. So our two solutions are negative 3 over 2 and 5. Now you're probably noticing that this parabola, or this quadratic equation, I'm thinking about the graph of the parabola, has 2 solutions, and so did the other ones in this set of problems. It is possible to have only one solution. Sometimes when you factor, you'll get both terms, both factors, identical. In that case, there'll be only one solution, or what we like to say, 2 duplicate solutions. And sometimes the solutions are not going to be possible to find using the Xbox method. In that case, it might be because there are no real solutions, like real numbers that make this work. Or it might be just because the solutions aren't rational, like they don't end up with as whole numbers or as fractions like negative 3 over 2 that are easy to find, okay? In this lesson, we're really focusing on parabola or quadratic equations that have solutions, either one solution or 2 solutions. More to come on those other situations in future lessons.